Ever crack open your phone and think, how they even make this thing? Or your coffee maker, all those tiny parts perfectly put together.
It's all thanks to the hidden world of tooling engineering. They're the masterminds behind the scenes.
Whoa, tooling like wrenches and screwdrivers.
Well, not exactly. Think of it more like the specialized equipment that takes raw materials and shapes them into those intricate products. It's about creating the molds, the dies, the fixtures, the stuff that makes the making happen.
So we're talking custom-made tools specific to each product. That's wild. And you're saying that's tooling engineering.
You got it. And our listener sent in a whole bunch of questions about it. Looks like they're considering it as a career path, right?
Yep, got career info, industry trends, even interview prep, the whole shebang. So in this deep dive, we're tackling tooling engineering head-on, giving you the knowledge to impress any recruiter.
Love it. Let's get into it. To start, it's not just knowing how to build these tools, it's understanding the why, the how much, the what ifs, it's problem solving at its core.
So it's not just being handy with a wrench, it's understanding the whole manufacturing process, from design to implementation.
100%. Take 3D printing, for example. It's changing the game. Imagine designing a complex mold for, say, a car part. Years ago, that was a huge process, lots of back and forth.
You'd have to make a prototype, test it, tweak it.
Exactly. But 3D printing, you can design and print that mold in a fraction of the time, test it out, make adjustments on the fly. It's a tooling engineer's dream.
Talk about efficiency. It sounds like this field is as much about innovation as it is about technical skill.
Absolutely. A good tooling engineer is always looking for ways to do things better, faster, more efficiently. They're constantly pushing the boundaries of what's possible.
Okay, so we've established that these engineers are the unsung heroes of the stuff we use every day. But what's it really like to be E1? Let's get real. What are the perks, the challenges? What's the path of success look like?
All right, let's start with the good stuff. And trust me, there's a lot. First off, the demand is through the roof. As manufacturing gets more complex, more automated, the need for skilled tooling engineers just keeps growing.
So job security is a big plus. That's always nice to hear.
Absolutely. And with high demand comes competitive salaries, even for entry-level positions. But it's not all sunshine and roses. It's a demanding field, high level of responsibility.
Right, because if a tool is designed poorly,
It can throw a wrench in the entire production line, literally. Delays, defects, wasted resources, it can snowball quickly.
high stakes. So you need to be on top of your game, always learning, adapting to new technologies.
You got it. The learning never stops in this field. New materials, software, techniques are always emerging. So you've got to be a bit of a tech geek, always hungry to expand your knowledge.
It sounds like a career that keeps you on your toes, but also one that's never boring.
That's the beauty of it. So to break it down, the career path usually starts with an entry-level tooling engineer role. Lots of hands-on experience, assisting senior engineers, really learning the ropes.
Like an apprenticeship.
Exactly. Then, as you gain experience, you might move into a junior tooling engineer position. More responsibility, maybe designing your own tools, managing smaller projects.
Starting to call the shots a bit more.
Yep. And finally, you reach the peak, the senior tooling engineer. Years of experience under their belt, deep knowledge of the industry. They're the mentors, the leaders.
The example profiles we have are impressive. Some have master's degrees, industry awards.
They're the ones who can troubleshoot any problem, mentor junior engineers, and really drive innovation. It's the natural progression. You start with the fundamentals, and then you keep building and growing.
So a clear path for growth. But before you can start climbing that ladder, you've got to land that first job, which means nailing the interview.
Oh yeah, the interview. Even with all the skills in the world, you need to know how to showcase them.
That's where those intriguing interview questions you found come in.
Right. This is your chance to shine. Like
Right.
one question we pulled out was, how do you ensure tooling designs are both manufacturable and cost-effective?
Ooh, that's a good one. You got to think about the practicality, right?
Yeah.
A design might look great on paper, but if it's impossible to actually manufacture,
Or if it breaks the bank to produce, that's the kiss of death. You want to show the interviewer you understand those constraints. Talk about a time you had to get creative to meet both those needs.
a real-life example, always a winner. It proves you can walk the walk.
Exactly. Another question that stood out was, can you describe a time you had to troubleshoot a tooling issue? Everyone loves a good problem-solving story.
Ooh, I can picture it now. The assembly line's down, tensions are high, and our listener swoops in.
And saves the day. Use the STAR method here. Situation, task, action, result. Lay it out clearly. What was the problem? What did you do? And what was the outcome? Show them you can handle the heat.
It's about proving you're not just a design whiz, but a problem solver, a critical thinker.
Exactly. And that's what makes a tooling engineer truly invaluable.
Okay, so we've covered acing that interview, but let's zoom out a bit. What's the bigger picture in tooling engineering? What should our listener be aware of as far as the whole industry goes?
Well, it's safe to say manufacturing is always evolving, right?
Hmm.
Driven by technology, new advancements popping up all the time.
Which is exciting. Keeps things interesting.
For sure. We already talked about 3D printing, but it goes way beyond prototypes these days.
Oh, yeah,
We're
yeah.
talking printing entire tools now, complex shapes that would have been impossible before.
Oh, really?
Oh, yeah. It's changing the game for tooling engineers, opens up a whole world of design possibilities. And then there's automation, of course.
Robots on the assembly line, that kind of thing.
That's just the beginning. We're talking smarter systems now using data, sensors, even AI.
Whoa, next level stuff?
Exactly. And tooling engineers are at the forefront of it all, designing tools that can work seamlessly in those environments.
So it's not just about the tools themselves. It's about how they fit into the bigger picture of the future of manufacturing.
Exactly. And speaking of the bigger picture, let's talk about where all this actually happens. You won't find a tooling engineer stuck in a cubicle all day.
Oh, so it's a pretty dynamic field then.
Absolutely. One day you might be on the factory floor, the next you could be in a research lab or at a high-tech engineering firm. Lots of variety.
I bet those labs are where that really cool cutting-edge stuff happens.
You said it. But no matter the setting, collaboration is key.
Because...
Tooling engineers are the bridge between design and production. They work with other engineers, designers, technicians. Everyone's got to be on the same page.
So communication is just as important as technical skills.
Couldn't agree more. You got to be able to explain those complex ideas clearly, whether it's to a colleague or someone on the shop floor. And speaking of keeping up, you mentioned earlier that learning never really stops in this field, right?
Right. So how does a tooling engineer stay ahead of the game?
It's a constant effort, for sure. Industry conferences are a big one. A chance to see the latest tech, new materials, software, you name it.
Like a crash course in what's new and exciting.
Exactly. Plus, it's a chance to network, meet other engineers, bounce ideas around. Then there's webinars, online courses, all kinds of ways to stay sharp.
Sounds like continuous learning is just part of the job description.
Pretty much. And of course, there's no substitute for hands-on experience, getting your hands dirty on the factory floor.
Right. That's where the real learning happens.
Exactly. Putting theory into practice, that's how you master the craft. Now, shifting gears a bit, let's talk about something everyone's interested in, salary expectations.
The million-dollar question. We know it's a high-demand field, but what can a tooling engineer realistically expect to earn?
Well, the Bureau of Labor Statistics data shows strong growth in manufacturing engineering, which includes tooling engineering. That means good news for salaries, even for entry-level roles.
Music to our listeners' ears, I'm sure. But what are we talking about in terms of actual numbers? What's the range from starting salaries to more experienced positions?
Well, it depends on a bunch of factors, location, industry, years of experience, but our research shows that an entry-level tooling engineer can expect a median salary.
And we're back, wrapping things up on our tooling engineering deep dive. Last time we were talking numbers, that all-important salary question.
Right, and the good news keeps coming because it's not just about those starting salaries. As you gain experience, you learn new tech, those 3D printed tools we talked about, maybe get some certifications under your belt, that salary can really take off.
So a career with upward mobility, both in terms of job titles and salary potential, that's a win-win. But we've covered a lot of ground here. It's probably a whirlwind of info for our listener. What would you say is the core takeaway, the big picture message about tooling engineering?
I'd say this. If you're someone who likes to see their ideas become reality, who loves to solve puzzles, who's not afraid to get their hands dirty, but also loves digging into the latest tech tooling engineering, might just be your calling.
It's like being an inventor, a builder. You're shaping the world around us one tool at a time.
And it's a field that's only getting more exciting, more in demand. With automation and advanced manufacturing growing so rapidly, skilled tooling engineers are going to be essential.
Which brings us to our final thought, something we hope will stick with you. We've talked about how technology is changing tooling engineering, but let's flip that around. With AI, robotics, all those advancements happening so fast, how do you see the role of a tooling engineer evolving in the next decade?
Will they be the ones programming the robots to build even more advanced tools? Will they become masters of both the digital and physical worlds of manufacturing? It's a future full of possibilities.
And we can't wait to see what those possibilities bring. So to our listener, we want to hear from you. What are your predictions for the future of tooling engineering? Connect with us on social media. Let's keep this conversation going. And with that, another deep dive comes to an end. Until next time, stay curious.